Test 1, 2. Microphone check. Mic. All right. Okie dokie. We're going to put the invite link in the chat. Then and see here, play a quick video. Today we're going to modify the Rodin coil Joule leaf that stands for the double pole switches and capture point. And we'll review a circuit by Pachuka. The links in the description. The video to this circuit is in the description. First we'll do bench strength. Hey Ben, what's up? I'm going to bring up the Rodin coil Joule beacon setting. I'll get some So we need to up that. There's an NTN. Resistor. We need a. No, I guess we can
Do it! Do it! Do it. Do it. Do it. Do it. Do it! Who is doing it? Do it. Do it. All of it. Do it. Come on! Do it now!
Okay, ready then. I'm gonna need a little time anyway. We're going to modify a Rodin coil to double pole, double throw switch and capture the flyback. That's what Ben's working on, a dual phase Rodin coil. And then we're going to look at a circuit that Pachuka created. He's experimenting with looks like self-running circuits. And I looked at this circuit, and I noticed he had a full bridge rectifier in there, and I was like, And I looked at everything, and I could actually see how efficient it was. So we'll go over that later. I gotta do this. Bring up this image. Picking out the components here for the schematic. Let's bring that image up. We're gonna need this battery symbol.
Сверкает звезда, юные чувства в домыслах ждут, чтобы забыть этот взгляд суеты. Весь смысл лишь мы, лишь мы в любви. Блаженство лишь мы, лишь мы в любви. Все чувства тают на устах твоих, все слезы в море уже не твои. Танцуют блики на волнах души, жизнь лишь миг для любви. лишь мы в любви. Блаженство лишь мы в любви. Весь смысл лишь мы в любви. Блаженство лишь мы в любви. Весь смысл лишь мы в любви. Блаженство лишь мы в любви.
One second, man.
Hey, what's going on?
Hey Ben, how you doing? Is
I'm
the
okay, how
audio
are
too
you?
loud?
You said what?
Is the audio too loud?
Just a little bit. If you could turn it down just a little bit, it'll be fine.
How's that?
Oh, that's perfect.
Um,
Yeah, I'll be right back. I see you're still working on the circuit, so
Yeah.
I shall return in about 5 to 10 minutes.
okay.
I was writing in chat. I was like, watching you design the circuit is like watching a painter paint, only it's more practical.
Yeah, this photo editor is pretty accurate.
That, and I don't know, I just like seeing you design a circuit. Anybody, the way their mind works, it's interesting. You can kind of see like how somebody would interpret something differently. I do have another circuit, and when we're backstage and not live, I want to go through it and run some ideas by you in terms of improving the circuit.
Okay.
But I'm not ready to open source it just yet. I want to improve it first, you know.
Yeah. Gotcha. Okay. Go down beautiful. Yeah, why not? Take it out later. Let's go. We need the two resistors, one potentiometer. Let me get a potentiometer symbol.
Okay, so it's coming together.
Almost there.
Almost there. It's not a hard circuit. It's a very easy one.
Yeah, I gotta still modify it.
Yeah, I'm talking about the original. Yours is going to be a little bit more interesting for me to get used to. I'm going to have to ask a bunch of questions when I start to build it. I know that for sure.
All right.
I've never actually used relays before, so just anticipating.
Well, this one has this is a transistor here. You want to do it with a relay?
Oh, you're doing a... Yeah, no, that's fine. I do want to build your relay, though, as well, at some point. No, yeah, do it with a transistor. Keep it simple first, so that I can get used to your method. And then we'll move on to the relay, because I do want to eventually move up to the relay that you have. I just, it's going to take some time for me to get used to relays. I've never used them before, and I need some help with that.
Oh, you mean the double pole relay? Okay.
Yeah, the double pole. Eventually, that's going to be I see that as the epitome of, like, the last, final, most efficient design for the Joule Thief that we're working with. Simply because you solved the issue that I've been trying to solve for a long time, Mike. You saw
So you already
right
you already knew the Joule Thief wasn't taking the Flyback, huh?
I knew. I had a suspicion.
It was using the.
I had a suspicion, but I didn't know enough about it to say either, right? But you came along and you said, "Hey, no, the Flyback is the different, the reverse polarity, so it's going to be attracted to the positive terminal." And I was like, "Oh shit, he's fucking right."
Yeah, right. I didn't notice that either, but yeah, the Flyback is being used in the load, but it's not correctly polarized to the battery.
Right, the extra that's not being used. It's like, and that makes sense because we're getting a strong AC signal, and it's an AC panel. It's not going to be lit up just by, the forward. So the back and forth is what's going to light it up, So that was always a question that I had that you just also solved. Like, you kind of, like, pieced together the last missing piece of the circuit, to be honest.
I forgot what PLE stands for.
So there are different reportings, but from my understanding, I thought it stood for peace on Earth. But but Chat AI seems to think it has two different meanings. Like they called it two different things. I'm not sure, but I've heard them directly say peace on Earth.
All right, let's do the mod now. Let's make this double pole switching. So to do that, you have to switch the positive and the negative of the source.
So we're gonna need a PNP as well, right?
Yeah, PNP, right?
Right, because we're working with an NPN already to deal with.
Right now, the one NPN is switching the negative side, the negative pole of the battery, and the positive pole is where we'll put the PNP. And the coil on the left is your trigger coil. So
okay, so the channel A is the coil on the left, so that's because it's directly hooked up to the potentiometer and the base, right?
Yeah, let me
okay.
change this Mr. Robotico music.
No, you're fine.
All right. Let me open up another. I'm gonna go use my modified Joule Thief to help get this figured out easier.
Okay, yeah, as a reference for sure.
Because it's practically the same, to some degree, it's the same circuit.
Right, you probably just have to do a few modifications, like simple things to get it. At least that's what I was thinking.
All right, so positive into the PNP, out to the trigger coil, to the resistors, to the negative. Okay. Okay, so I'll just use that as a reference. Let me do that. Okay. Where is the PNP? Should be here. EPN. I have that.
Lights are flashing, energy supreme.
Yeah, I mean, it's worth, if you could get it, I guess, I mean, transistors use a little bit of power, but this, if you can get it working with transistors and relays, I mean, it doesn't matter. You could switch the transistor to a relay. You want to do it with relay?
The system, sorry, the system is so sensitive to different components. I want to test it with the relay just to see if it has any other effect, you know? It might not be as efficient as the transistor or MOSFET, you know, who knows?
Well, because the relay version has less circuitry than the transistor.
Right. I don't know, with these kinds of systems, sometimes it's hard to predict their behavior, especially with the Rodin coil, at least. When you're connecting it just does weird stuff, so I just want to test it just to be sure, you know? Plus, it's really cool what you did with the Joule Thief. I have to say, like, I've been working with the circuit for a while, and I've seen a lot of different modifications, and this is the first one where I'm like, actually, wow, like, this is actually going to be really useful.
Let me do that.
Because regardless of if there was a load attached to it, in that video, raising the voltage potential on the battery, that's no small feat. You know, that's huge. That's massive. So, you know, hats off to you, Mike.
You'll remember, you know, you got to remember Ohm's law on that, though.
Yeah, it's probably not going to last indefinitely, you know, like it's an indicator that it has the effect that we want it to have, you know, it's doing what we want it to do.
Yeah,
when
well,
we apply it
yes.
to this system, I think it's going to increase the efficiency for at least my system too. So
seeing the voltage rise above the
source
rise above the source voltage is an indicator that the flyback is going to the source.
That's awesome. So see, I didn't know that, and that also makes sense.
That's your indicator.
Yeah, that also makes sense when we look at the other setups that we've seen that with, you know, like, so it's piecing together, and you provided a vital, crucial piece to that puzzle that we were missing for a while. This is why I wanted to collaborate with you guys. You know, you guys are my peers. You know this more than anybody. You know this topic, these subjects, these circuits.
If it wasn't for Bedini working on Bedini's schoolgirl circuit, I wouldn't have figured out the flyback. I never even knew about it.
Right, but I figured since you were so used to working with Bedini circuits and dealing with the flyback,
I mean, I heard of flyback drivers and all that stuff, but I didn't know exactly what. I didn't know that it was the recoil, that COILS recoil. I didn't know
that. The
that.
Bedini circuit is not as simple as he makes it out. John makes it out to be. Trust me, like, the tolerances to get it just right, you know, it's not that straightforward. It's a process, and, you know, anybody who can learn that process and adapt to it, you know, for further circuits, I think it's really important. You know, because it's one thing to just replicate what John did, but it's another to understand what he did and, like, build upon it, which is what you're doing, you know?
Right, I replicated it, but I didn't understand it. Okay, I built like 5 or 6 or 7 of them. And by the time I built the 10th one, I finally
something snapped in your head, and you're like, oh,
yeah,
yeah.
So, I realized that I don't know what I realized. I must have realized that the flyback was. Yeah, I must have realized about the flyback, something like that. And that it was flyback or something like that. And then I looked into Flyback and saw that the polarity changes on the Flyback, and I was like, oh.
Interesting.
And then I was like, okay, so how do I get that polarity reverse back into the battery? And it came to me that I messed around with a double pole relay before I had a magnetic stirring device was making colloidal silver, and I wanted to stir one direction then the other to keep particles from forming, you know? So I used a double
Right.
pole relay to do that, to get the motor to go backwards and forwards every so often with a timer.
Interesting.
And that's where I realized I can do this thing, you know? I didn't know
But that's
exactly
a brilliant
how, but
indicator too. I didn't even think about that. We should actually try that with the circuit I have now, hooking up a motor, just to see the polarity effect, because you can see the polarity go forward and then backward and physically see the motor reverse. That's like a visual indicator of like the energy movement. I don't know. I think that
Hey,
could be a
Mikey.
brilliant way. You said what?
no, my dog's starting to snoop around trying to eat the cat shit.
Oh boy.
Yeah, back in the cage, buddy. You're gonna learn one of these days. There's no snooping around while I'm on the phone or whatever.
You gotta listen to Big Papa.
He thinks he can do whatever he wants.
Is he still young?
Stop chewing your feet. No, he's just
Stubborn?
he's one of them dogs that has problems, you know.
It's okay. I love animals.
So we gotta go back to the negative. That goes out. So we'll do that.
Yeah, you had the PNP hooked up to the input.
So put it here. Think about this. Put it there, and then we'll move that line to the base. Okay. That goes back. Move that to the base. Okay. And then it hits the trigger and goes to the right. Goes through there, hits the base. Back to negative. And the collector goes to there.
That's right. Both the bases are connected to either side of the channel.
And then that goes to the power winding. What? There's the load. Why is the load there? It's over there. So plus goes. Okay, right. So this is a little bit different than the.
Right. It might actually take some experimenting and trial and error to get it to work correctly.
Oh, I see. I see. Never mind. We're trying to send a plus to this. Can you see the cursor?
Yeah.
Trying to send a plus right here.
Okay.
right there. Plus from the battery. So
It's different because these two channels are locked because they're connected. They're phase locked.
well, well, we're looking at this right here.
Hmm.
When that's closed, right, and this gate right here is closed, the plus should channel over to here.
Or
Look at
should
your
you put it on the
look
opposite
at-
end of the channel?
Look at your circuit at the top left. The plus channels over there.
Yeah, that's the
Right, but
positive output.
look at your circuit top left. The transistor is switching the negative side. See the ground?
Yeah. Oh, I see. So you want to switch the others? Okay, I got it.
See here's the negative side of the coil.
That makes sense because the collector is hooked up to that start of channel B. You want to hook up the other collector to the end of channel B.
I'm pointing at the positive plus from the battery, goes in there, comes out the negative side of the coil.
Right,
to the
exactly.
to
Yeah.
ground.
Yep.
Okay.
The one with the arrow is the end of channel B, I believe.
Yeah, or where the plus of the battery goes into the charge coil. The other
Right.
coil's your
Part of
trigger, your frequency coil. It makes
the input
pulse.
15 volts or whatever.
So we need to
Okay,
send
that
the
makes
plus
sense.
into there. So we send the plus into there. Okay, we got it. We got it.
So do you disconnect the two channels and just hook up the collector to the end?
Well, remember, we're double pole switching. We
Yeah.
got to switch the plus and the minus side of the battery to the coil. Right now, this transistor right here is only switching the minus side. That's your minus.
Right, it's only messing with the flyback, you're saying?
It's taking this end of the coil and bringing it to minus through the transistor.
Bringing it to ground. Okay.
Okay, now this is your plus, which has to go in this side of the coil. Through the coil to minus. We need to double pole switch. We're only switching, this is a single pole switch, and we add this is the double pole, the second pole. Each pole represents plus and minus. Double pole means plus and minus of the source.
Right, so it's switching back and forth.
Two polarities, the positive and the
Okay.
negative.
Right, because with this one, we're just getting the one, whereas this double pole will get
Right,
both
this
of
is
them.
single
Okay,
pole switching, which is only switching the negative of the battery.
that makes sense.
Oops, that's incorrect. Well, actually, I can go right to here.
Oh yeah, the junction.
Right there, near that sends the positive to this end of the coil. When this closes,
Mhm.
the plus of the battery will go right here.
I might be able to even modify this like you have it with the circuit board, the printed circuit board I have, instead of doing a breadboard version. That's very simple.
And it looks like we're done.
Yeah, it
Only-
looks very straightforward. I mean,
Only
I
thing-
can't
Oh,
imagine it
oh,
being.
wait. Gotta do this.
And like I said, we might have to mess with the potentiometer and the resistance and all that on the base, but other than that, oh yeah, the negative output.
I believe that's just a neon.
Yeah, just in any kind of HV lighting, because it does produce high voltage. Just for anybody trying to replicate this.
On the schematic, it says it's a neon.
Yeah, we use a neon just because it, all the voltage. It's easy to easier for a neon to take all that voltage.
Okay, so
In the club where the lights ignite the night.
you want to put
Beats are pumping, taking
yeah,
us
let me move that over, I
dizzy
guess.
heights.
I guess I can just do this.
People move
I'm gonna add the lamp
and the
just, in
vibrations
case the flyback tries to trigger the circuit again.
heartbeats sing.
So on the PNP, is that the collector right there, or is that looks like might be the collector,
Feel the bass, it's a
or is the opposite side the collector?
The left side with the arrow,
Yeah,
that's the emitter,
that's the emitter. Okay, and you're connecting the emitter to the base.
the base.
Okay.
The positive goes on a PMP. The positive doesn't go in the base; it goes in the emitter and out the base.
Okay.
On the NPN, it goes in the base and out the emitter.
Okay. I think I get it. Or
Yeah.
at least I'm starting to get it.
It's the opposite. It's designed that way so you can do different kind of switching methods.
Right.
So this lamp here,
Oh, so you're gonna put in another protection lamp, or
just so that the flyback doesn't.
and that could act as an indicator too, right?
Yeah, it'll indicate if the flyback's trying to trigger the transistor again, which you don't want it to, but
So if it lights up, it's
That-
not working.
it means that you need to add capacitance to the battery side.
Oh,
Or-
I see. So
or-
in that case,
or-
you would add the cap bank.
Yeah, or you can add more batteries to suck up that flyback so it don't go and hit the transistor.
Gotcha.
More amp hours, more capacitance on the battery. We'll
Right.
do that. We'll
So
do
what is
that.
it doing? Just providing a bigger like sinkhole for it to sink into when you increase the
Yeah,
battery?
I mean, if this light goes off, you want to add more batteries.
Okay.
You don't want it to go through the light to ground because then you're going to waste the flyback.
I
you wanna add
probably
You want to add, it's just there to protect the transistor so you don't lose the transistor. So,
Right.
and if it lights up, you know that you need to add more capacitance on your source so that the flyback gets fully absorbed into that battery or batteries.
So in that
parallel.
case, yeah. So I'd run this as is, and then if I see that, then I'd come back to you and be like, how do I attach a cap bank here?
Well, you know, cap tank may not do it. A cap tank may
a regular-
just charge, right? But a battery will. I mean, more batteries will.
Oh, I see what you're saying. Okay, yeah, that makes sense.
There's no way if you put like 10 batteries in parallel on the left there on the source, there's no way the flyback's going to get by that and hit your transistor. Unless the batteries, those 10 batteries are all fully topped off, maybe then.
Hmm.
And then when that light goes off, you know your batteries are topped off.
Interesting. Well, that's interesting. I think we'll include that in the schematics. You know, like just as a side note, if the indicator goes off, add more battery to your source. That's a good.
Yeah,
for
you
anybody
could
watching.
put that right here on the drawing if you want.
Yeah, no, I'll do that. I'll do that later. You know, or it's just a side note that I'm recording, so I remember to do it.
Oh, okay. So we could just put that, you know, in a little bit of text here to.
To ground. Oh yeah, yeah, I gotcha. And honestly, it's still very simple. It's still a very simple circuit, which I like. I don't like to keep things too complicated.
Okay. Now, your source power on this is 15 volts.
Right, but it'll work with anything from like
1K, 1
9 to
meg,
12.
2 watt resistors. We got to put that in here.
Yeah.
So this is a 1K.
1K 2 watt. Yeah. So make sure, like, I mean, they don't need a 2 watt resistor, but I definitely would recommend it just in case you get a lot of current going through that base. You don't want to burn it out, you know. But I mean, Michelle did recommend a 2 watt specifically for this setup because it does.
Yeah,
produce
1
a lot.
watts don't do very well.
Yeah.
Mm.
And to be quite frank, this circuit produces a lot of energy. I've had it burn up.
I mean, there's 5 watt resistors too.
Melt my wires.
Yeah, you need if you have any wires from getting all melted, you need to increase the gauge on it. What is your problem? Sometimes I wonder about this. program. Okay, so the other one is 1 meg.
Yeah, it's the carbon type pot too.
You want to put that in there?
Yeah, the carbon recommended because the other ones burn up faster, I guess.
2 carbon.
Yeah. A potentiometer.
Hmm.
Yeah. Just so there's no confusion.
I'm getting really good with this program.
I can see that.
What else? Your transistor is. I wonder if we gotta find a PNP. Look on your Google search, your MJL21194G complementary PNP.
PNP. Yeah, that's what I was just thinking. See if we can find.
It's not that. It's not that model number, but you want to get the complementary to this model.
So I'm gonna look up.
Just type in MJL. Do you see it on the screen or?
Right, but I actually work. My system works better with the E13009.
Okay.
So I'm gonna find that one.
So what's that number again? Let me change that transistor.
So that's a MJE 13009.
13009. MJ.
Yeah, it has a higher switching speed.
Okay. I think I've worked with the MJEs before.
Gerald
MJE
recommended it because he works with it a lot.
13009.
Yeah, and Gerald recommended it.
Oh, wait a minute. That's the NPN. I need the complementary.
Oh
PNP.
yeah, I'm looking that up right now. There is no direct standard PNP complementary counterpart for that one because it's a specialized NPN high voltage, high speed switching power transistor.
Yes, there is.
Interesting.
Yes, there is. Just type in PNP. Just type in MJE 13009 PNP, and NPN, and AI will give you the PNP version of that with the same rating.
So it says MJE 5850.
There you go. It's a PNP, right?
Yeah, I believe so. I'm gonna double check because AI sometimes makes mistakes.
What was it? MJE 5850?
5850, yeah.
I think I know this one. I know this number. This 5850. I've worked with PNPs, NPNs, and when I was in ITT that was like when I was 22 years old or something. Long time ago.
So it is a PNP, and then it's basically there's 3 of them. There's 5850, 5851, and 5852, and they all handle 400 volts up to 8 amps.
Oh, that's a nice one.
Yeah, so that's a good match for because the 13009 is a high voltage, high current, fast.
So you want to use the 5850 as your PNP?
Yeah, let's try that.
You can always change it later.
Yeah, we could always adapt. That's true.
There you go. That's your okay. Now we got to do the diodes and the connect the diodes to the flyback side of the coil. What the hell is that?
That's right. We need some diodes for the flyback.
And that would be, we need a channel going from the negative to the start of the drive coil. So essentially we can go this way. Well, actually we could just do this.
Oh, there's a correction for one of those texts.
Which one?
The potentiometer is actually a 1 megawatt.
Mega ohm.
I'm sorry, mega
No
ohm.
way, it's megawatt.
My bad.
That don't exist yet, man.
It's a 1 mega potentiometer.
It says, oh, it says 1K. Yeah, I'm sorry. Let me change that.
Mega ohm. I'm sorry. I don't know why I said 1. That thing would be fucking huge.
People will be, running to the store to get that one. Where does that exist? That can handle a lot of, maybe it does exist. I don't know.
Industrial wise,
Probably if anybody uses stuff like that, it's the grid.
Yeah, for sure. I mean, they have those big ass knobs and dials, right? So one of them's got to be a potentiometer.
The grid probably has stuff like that.
Yeah.
Power grid companies. I gotta change that. One mega ohm. They look good.
Yeah. 1 minute. Yeah.
See anything?
You said we needed to put a diode in there for the flyback. I think that's the only thing that's left, right? Unless we put it in the cap bank.
That's on the positive. Yeah, no worries. Yeah, the diode. Well, this is not going to look exactly like.
Right, but this configuration is slightly different, so it's.
Probably should put the diode there. Okay. Go to 200. Maybe 150. I was looking at, I'm subscribed to this channel, Pachuka. I think he's Russian or something.
Mhm.
And he has this, his circuits looks like self-running, lights and stuff.
Right. Yeah, you
I'm
were
going to go over that
that.
if you want to stick around.
Yeah, I'll stick around for a little bit and catch that because that was interesting. You were speaking about that earlier.
I was like, I'm looking at it. He's just tapping the positive and it's running on its own.
Interesting.
So, and I looked at the circuit and I could see how he might have achieved that.
You might have. Okay, cool.
And so I wanted to explain what I'm seeing. So let me delete this. So it's the flyback diode.
Right, that's facing the negative return, the negative terminal source.
Yeah, it basically going back to the negative of the battery. That's all that is.
Mm-hmm.
Don't let it confuse you. It's taking it straight to the negative of the battery. I'll go over this before we consolidate.
Okay.
Just cleaning up the messes here. Look at that nice corner.
We like us some right angles.
Let's see. All right. Oh, that's good. So that's your flyback. Now, should I put high voltage in there? Probably. HP.
Yeah, it's always good to warn people.
HV. HV's enough.
Like, surprise! It's producing high voltage.
Well, I mean, this way they can choose their own diode. There's all kinds of diodes that are high voltage, so they can use Schottky. So, yeah, the positive. Oh man, did I do that wrong? Yeah, I did. The positive hits that side. Oops. Okay, that's no big deal. I put it on the wrong side. Let's delete this. Take it to the positive.
Oh, I see what you're saying. That goes to the positive battery terminal.
Right, because that's actually the negative side of that side of the coil gets hit with a negative from the battery,
Mm-hmm.
and it turns to a positive.
That makes sense.
So it turns to a positive flyback.
Interesting.
So you want to send that positive flyback to the positive of the battery,
Mm-hmm.
not the negative. I had it going to the negative here.
In the club where the lights ignite the
Let me know if anybody's... Nobody, huh? Too early. I see when I go live late at night, it's like everybody's showing up. All these late birds.
Yeah, it seems to be only certain times that I get people like really active too on my streams.
Everybody's eating dinner, watching movies right now.
every heartbeat syncs with the rhythms we found.
So this is your positive flyback coming back to the battery.
It's a journey we embrace. On this dance floor,
Okay, that makes sense. You get the diode facing the positive.
through the night.
Yeah.
We'll soar in this euphoria. We always want more. With every beat, we leave the world behind.
So yeah,
This tech house
let me just explain real quick. In green, this is your plus of the battery here. Okay, it goes through this transistor and it hits this side of the coil. You see, plus,
Okay.
and the minus is down here. Gets connected through the transistor
shadows as the strobe lights flash.
to this side of the coil.
In the air, we're ready for the clash.
The minus of the battery. Okay, not the flyback. So that's the polarity of the battery.
Okay.
This in red is the polarity of the flyback. That's your flyback polarity. That's what happens when these open up. When those open up together, the
Mhm.
coil collapses and reverses polarity and flies back.
Okay, that
And-
makes sense.
And so this plus has to go to the plus of the battery.
Mm,
That's your plus of the battery. You see?
right.
You're getting it now. I know you are. It's there. It's confusing, you know. This stuff can be confusing at first.
Well,
Once
it's
you get a
making
grip for it,
sense
grip
though,
for it.
and it's symmetrical because we're dealing with two different components. You have one transistor handling the flyback and the other handling the forward.
Right. No, both transistors are handling the
Oh, I'm
forward.
sorry, they're handling the flyback, but with different polarities.
Both transistors close together,
Mhm.
charge up the coil. It closes the plus of the battery to the plus side of the coil, the minus of the battery to the minus side of the coil together. It opens up, lets the coil collapse and fly back in reverse polarity. And the diodes are handling that, not the transistor.
Do you
The
think
diodes,
that any of the flyback is going to go to the load and it's going to
which is
split?
good because,
Yeah. We
which
want it
is
to go
good.
to the load a little bit, yeah.
Well, what I'm saying, it's good that you don't have the transistors handling the flyback because you can't hurt them. And you have diodes doing that. And they're hardwired to the battery, so there's no switching the flyback. It's hardwired. There's no switching the flyback to the battery. It's permanently connected. You're only switching.
Do you recommend putting another diode where I usually have it, or just is that enough? The one single diode up there.
No, one more diode right here on the negative flyback side of the coil, right here.
Okay, but no other diode is required on the positive.
No, just
Usually-
one. Only use
Yeah,
one.
because that basically serves as the diode that I have up at the top. It's just connected.
I'm
to a
using the
different output.
ground symbol to make the less lines here. Okay, the ground is the same point on the circuit. It's the negative of the battery. Wherever you see that ground symbol, that's the negative of the battery. Okay? That means that's where you connect that part of the circuit to the negative.
Right,
So I'm just-
but you see how I have a diode on the positive output rail right next to the neon.
Where?
So
On your circuit?
yeah, on my circuit,
Let me-
is that diode taking the place of the one that I have, or are we gonna still add that one?
Where do you see a diode on your circuit?
So
neon.
it's actually not drawn on here, but it's an addition that we had on a different schematic. It's
Oh, that was just to keep the flyback from hitting the transistor, but it won't hit the transistor because it's going to be open.
right. So that's why I'm asking. We don't need an extra diode. That's taking the place of the diode I already used.
Who told you to put the diode there?
So that's just a common thing that we've been doing with the circuit. It makes it more efficient.
Where was the diode going? Let me draw. Was it going?
So
here?
yes,
Wait, hold on.
pointed towards the load.
Why can't I draw on this? Oh, never mind. Was it going here?
Yeah, that's exactly where it was.
Like that?
Yeah.
Why would you do that?
So it's counterintuitive, right? But for some reason, it makes the LEDs brighter and it makes the system a little bit more efficient.
Well, okay, hold on. You did that because, let me explain why you probably did that. Hold on. So when you put the positive of the battery right here on the coil, and the negative here, when you close the switch, that's what you're doing. When you open the switch, that polarity changes like so. And now you have a positive flyback going right here through the load, through ground. If you had the diode here,
It blocks it.
it blocks it from coming into the collector and possibly damaging the collector, but there's no reason why it would because the gate's open. There's no path for the flyback there.
Right, exactly.
If you find that the flyback is going in the collector, then that's an
Mike, the
anomaly.
only thing that I can think of is why it works better is exactly what we've been talking
Well, it
about.
rectifies the flyback for you. It rectifies
Yeah,
the flyback to DC.
It rectifies it, but also I believe that since we're talking about circuits in terms of field coming first before electricity, I think it might be, preserving
The
the diode
diode
a
would
little bit.
rectify it to DC, and the light would work better if it's a DC light.
No, it's not a DC light. It's an AC light. That's the thing. Usually you put a diode there and it would make the light dim a little bit less. So I just think it's blocking the electron flow from the battery returning to the positive and, you know, separating that effect. Like you said, it's a rectifier. The diode is a rectifier. But what it's rectifying is the forward and the backward. Because remember, in my
I see what you're saying. It's possible, yeah, that the coil can, if the light doesn't take it, then yeah. But it's not going to go through the transistor. The gate's open.
Right, exactly. Open. But remember, in the system that I'm working with, we're picking up
always
10 positive volts and then 168 negative volts. In any other system, that would destroy itself. You know, picking up that kind of difference in negative positive voltage on the same output. But that just proves we're separating, you know, the forward and the backward. The backward just has nowhere to go. This gives us a path for the backward.
Whatever. I mean, here you see the flyback exiting through the load, the ground. That's where it's going to go. It's not going to go through an open circuit here.
Right, exactly.
So, and whatever this guy don't consume,
it's going to go up to that positive. Yep.
Okay, it'll go back to the back. Whatever the light doesn't consume, it'll go to the back of the back.
That's exactly what we wanted to do too.
So that also protects the transistor from any anomalies of the flyback somehow getting through an open gate, which is not possible. So it should keep
the transistors a little cooler, running cooler, or
what I'm saying is when the flyback happens, this gate is open. There's no path. There's maximum, not even maximum resistance. There is infinite resistance there. There is no path for any energy or voltage to go through that transistor when the flyback is happening, because that's when the transistor's open. And that's just, you know, I don't know why the light got brighter. Maybe because, you know, when you have a voltage drop, your current goes up. So a diode creates a voltage drop.
Right, but that can make sense. Honestly, that can make sense.
When your voltage goes down, your current goes up.
Right, in proportion. So that is actually a valid explanation. I'd have to look into that a little bit.
So if you put a voltage drop there, the current would have to go up to get through there. It raises the current to get through that resistance, you know. Mm-hmm. A voltage drop is basically means there's a resistance in the line.
Well, I think the main indicator, though, the main thing.
But remember, diode components use up power. So the more you put, you know.
Right, but I think the main important thing to consider is that we're getting such a difference in positive and negative output that it kind of proves the forward and the backward aren't fighting each other in the same wire. Otherwise, in normal circuits, that kind of effect would just burn up components. It would destroy the circuit.
Say that again.
So when we hook up a grounded probe to the output, we ground the probe to the negative and then hook up the probe to the positive. We get 10 plus positive volts and then negative 168 volts. That kind of differential between positive and negative voltage on the same output rail, you know, it's not common, right? When you get that in a circuit, usually it means there's going to be a lot of heat and your components are, you know, going to fry because it's fighting each other. But in this system, it's stable and it's no heat, so it's not fighting each other. So it's kind of indicating that the forward and the backward are dancing in a way that it's producing less resistance, if that makes sense. So I guess that's just something extra we have to consider. But I just think your addition is going to do that, take that negative energy and direct it in a better way. We're wasting some of it in the load, quite frankly.
Oh, that's very blurry. That's so blurry. Let me just take that. All right. It's a blurry. Why is it so blurry?
There was a what is that, Photoshop? I think Photoshop has an AI feature now that you could just box something and then tell it to, you know, enhance, which is pretty cool.
Yeah. So we got the dial now, put it right here. Let me see. Rotate. There you go. So now, let me just clean this up a little bit. Okay. All right, so another high voltage diode. And we're done. This looks cleaner than my circuit because I used the ground symbol. When you use the ground symbol, you're able to remove lines.
Less messy.
Less lines, you know?
Yeah.
Circuit, but you still need to make those paths anyway when you make the circuit. Because... All right, so now you ready?
Oh yeah.
So anything I'm missing here? Oh, let me put in the lamp part number here. Neon bulb. You want to put neon bulb on that lamp, or?
I mean, I could always do that if, yeah, because it doesn't really require a specific bulb.
I just put, where is that? Hey, Anthony. He stopped by. I didn't see him. It's SMIL. FUI. Put that part number here. SMIL FU. SMIL FUI dash 5. Is that an S? No, SMFY 291. SMF42.
Mike, you should have one of those stalls in the mall, and you should have a shop. I'll design your circuit.
Circuit, what do you call it? Graphic design of circuitry or something.
Yeah, put it on a t-shirt too.
That's the right part number, right? SMF42. Yeah, okay. All right, that's the part number. So now let me crop out. We just modified your. You want to put in channel A start, channel B start. I can do that. You want to do that?
Sure. I mean, the dot kind of.
I'm a short-term channel A start.
Not everybody knows what the little dot means.
I'm gonna just put CH for channel.
Yeah, don't type it all out, or just put A and B.
Channel A start. Does that work? Or just A start? Put A start. And then
Yeah.
B start. Oops. And let's put it in bold. Is that good?
Yeah. Yeah, that's good.
And that's pretty much it. There's no confusion here. R1, you don't need to put R1. So now you have a double pole, the same circuit, piece on earth circuit, but a double pole switch where the flyback hits the battery. You want to put 15 volts on the battery, or?
So that's what Michelle recommended, but we don't need to actually put in. We could put 12 volts, and I would recommend 12 volts because 15 is a little bit high, just for what I'm doing with it. But you can put 15 into the system. I work with 12.
All right, so we'll put 12.
Just anybody listening, for reference, if you do use more than 12, you will need a higher voltage rating for your neon.
Be right back.
No, you're good.
Cooking bacon chicken.
So this looks like it could be fairly straightforward for me to build and modify with what we have already. I can use the RHRP 8120 diodes, the high-speed diodes with the 25 nanosecond recovery window. All I need to do is order a PNP MJE 5850.
You could also use the double pole relay and take out those transistors and put each of the two relays in the double pole. You put one in each transistor position.
Okay.
That
Yeah, I don't think
the pins on the relay will help you get that done. If you want to do that, I'll help you.
Yeah, well, definitely, but I'm gonna try starting with this since it's so straightforward, and I think I can easily just slap on some of these modifications to the PCB we already have. I'll try it. If not, if that doesn't work, I'll definitely try the breadboard before we go back to the schematics.
I'm gonna crop out. Is there anything I'm missing here?
I don't think so. I'm looking.
You want to zoom in on your circuit to verify?
Yeah, could you zoom in on the left hand so I can see both of them, yours too? Okay.
Well, you know that's the lamp over there.
That.
Chase the night, let it take you higher.
Did I mess up there? No. Okay, yeah, that's right.
I'm trying to check the diode direction. That's all right now.
Ooh, wait a minute. I gotta take something out.
Yeah,
You don't see it, do you? No, there's an error.
There's an
Let me
error.
see if you see it. It's
Yeah.
a circuit path. Let me see if you find it.
It's a circuit path. I'm seeing something in one of the diodes. Is that what you're seeing?
No.
No,
Maybe.
so
What?
I'm not seeing something.
What are you seeing? Which diode are you looking at?
I'm looking at this diode all the way to the left on your circuit on the bottom.
Left bottom.
So
There's top. Yeah, a high voltage diode? There's only two diodes.
it's right next to the source. So there's two diodes next to each other. The one on the left.
That's not a diode. That's the emitter on the transistor.
Oh, that's an emitter? Oh, I thought that was a diode.
No, well, you know, in transistors, they're like diodes.
It looks like a similar symbol.
It is
for
a diode. There is a diode in the transistor. It's kind of like a diode. It's a variable diode.
That's not. That is a diode. Those are two diodes at the source right there, right? One of them is facing the positive, like we have on ours. And
On
one
the
of
plus
them,
of the battery?
yeah.
No, that's the emitter of the transistor.
No. So I see two diodes right next to each other on your diagram on the bottom.
Oh, that's my diagram.
That's what I'm looking at. I'm
talking about the one we just drew out.
No, my bad. I guess I didn't make that clear. I'm looking at your diagram, and I'm looking at the one diode. It looks like one of them's facing the positive, but the other one, I can't tell which direction it's actually going.
Okay, hold on.
But I'm assuming
You're
that's
looking
not
at
this
over
thing.
here, right? Okay, you're looking at this, right?
Exactly, yeah. And that's facing the emitter of the PNP.
Okay, so plus from the battery charges the coil with plus. The coil flies back negative here and plus here.
Mm-hmm.
Plus flyback goes through the load and through this diode to plus battery.
Right.
Out the negative to this diode. Remember, that's plus energy going through that diode.
Oh, so it's
Plus going through the diode. And the same plus cuts through the battery and goes through the diode to meet the minus. The plus has to meet the minus.
gotcha.
For the cycle
So no,
to complete.
that's a good tip
this
that you just gave
plus, this plus has to meet the minus for it to work.
me. No, Mike, that's a good tip you just give me, because what you're doing here is you're drawing out the physical, you're mapping out the plus and the minus, and you're matching them, and that's a good. So I should do that from now on when looking at the circuit flow.
Yeah. It's not going to
Okay.
work if the plus don't hit the minus. You're not going to have.
Right. No, that makes sense. It's just, you know, a matter of methodology, and you just
The same way the plus in the battery has to hit this side of the coil, and this other side of the coil has to
Yeah.
hit the minus of the battery.
right, because we're going from a lot of potential to a
If
negative.
you want
we
that,
to
if you want
equalize.
that that coil to charge, that's what has to happen.
So I don't think I'm looking at the same thing you're looking at, though. You said there's a mistake.
Oh yeah, there's a mistake. Yeah, let me show you.
Yeah.
Okay, so when I send plus to here to trigger this transistor, and out here to negative, which lands right up here to negative.
Right, goes back to that source.
Plus to minus. That's the plus to minus path. And that will close both of these transistors, right?
Mhm.
Right. But you don't want, you don't want this plus going through here and out here to ground.
Oh, I see.
Because then you're shorting out the battery.
Right.
You're just shorting out the battery. You're losing power on the battery. And that will close this gate, but it will never make it through here and close the other.
Yeah, it's not even gonna excite the coil. It's probably just gonna.
It's just gonna drain the battery.
Yeah.
So it's a good thing I saw that, because you would have been like, "What's going on? My battery's dying, Mike. What the? Did you design here, man?"
I didn't expect us to get it right the first time, honestly. With these things, sometimes
No, that's why we got to look at it. We got to, look at it
exactly,
closely.
and
draw it out,
you know,
draw the paths and everything, and you'll find it when you do stuff like that.
And for me specifically, sometimes I don't see things until I actually test it on the bench, and I'm like, okay, so this is something that I need to correct.
That's got to go. That cannot be there, dude. That would kill your battery, and you'd be really pissed off at me. I mean, it would just close one diode, act like a switch to short out your battery. You'd be like, you'd be sending me hate mail.
So the channel A and B,
you probably won't even bother me. You'd be like, let me try another battery. Kill that one too.
the channel A and B, they're still connected through the transistor.
There you are. Now we're good.
Okay.
We took that out because. All right.
Interesting.
That path would have basically, the plus and the battery would have gone through here.
Mm-hmm.
Don't worry about this. The diode's blocking.
Right, it's not going to go that way. Yeah.
It's a high voltage diode, but it will also block low voltage. I'm pretty sure.
Yeah,
I know it will because I've already tested it. So I didn't have any problem with these high voltage diodes blocking the low voltage. I didn't expect there to be any problem either. Because why would it?
I've had a lot of success with the UF4007 and the RHRP 8120.
What are those diodes?
Yeah, the high-speed diodes.
Oh yeah, 1N4007.
Yeah.
UF. Where do you get UF from? That's microfarad.
No, the UF stands for ultra fast, I think.
Oh, really?
Yeah.
It must be a Schottky or something.
It's not a Schottky, but I think it's one that Daniel Nunez would work with. But yeah, the RHRP 8120 actually works the best in my system. It's a remarkable diode, to be honest. I would recommend messing with that one, the RHRP 8120.
All right, so look, let's go over this, make sure everything's correct. This path again, why did I take it out? Because the plus would go through in the emitter out the base. Why would it go in the emitter? Because there's a path to the negative. The plus can hit the negative. This plus can meet the negative through the emitter out the base, right here, the negative. Okay? That's why it would go that way. So we took that path out, right? So we don't have that problem now. We want it to go through.
Now the channels are connected to the emitter of the
transistor. So the plus goes in the emitter, out the base of the PNP, through the trigger winding, through the 1K resistor, through the potentiometer, in the base of the NPN, out the emitter to ground to meet the negative. And now you have successful path of your 12 volts is kind of a lot, but I guess these transistors can handle that.
Interesting.
For trigger, you can, the 5850s and the 13009 can handle 12 volts on the trigger. I guess so. Right?
You said what? I
mean, these transistors can handle this kind of voltage on the base?
Oh yeah, definitely. The 13009 is pretty beefy.
So basically the base emitter voltage of these transistors is more than 12 volts.
Yes. Yeah, it requires a higher it's 12 volts. We'll trigger the base.
Look it up. What's the base emitter voltage of the MG8?
I have it right here. Hold on.
Oh.
here.
Testing 1, 2.
Oh, there it is. So I have a list of transistors I've been working with and all their specs. The E13009, approximately 1 to 2 volts or watts. I can't remember if that's volts or watts, but 1 to 2 for the base. I think that's
12.
Maybe it's watts. I don't know.
Read me the transistor number.
E13009. I know I had a problem with this chart.
It's not E.
E
MJE.
Yeah, MJE 13009.
Okay, hold on.
But sometimes it's just
MJE 13009. Data sheet. Data. You just type data and it gives you the PDF.
But it's able to handle 400 volts and 12 amps.
That's on the collector emitter.
Now to trigger the base, so this table didn't translate right. I can't remember if this is watts or volts, but it's 1 to 2 on the base.
Look, I'm going to go over the chart right now. We're going to find out.
But it definitely doesn't need 12 volts to trigger the base. I've triggered this transistor base with a lot less voltage.
And maybe just download this instead. Hold on. It's better for me to download the and open it up with PDF, my Adobe. I got more control like that. All right, do you see that? You see that? So,
yeah,
base emitter. It's actually BE instead of BE.
So mine is got L at the end instead of G. I don't know if that matters. It might be the same one, but
collector cutoff current. On characteristics. DC.
Yeah, the L just might be a form factor thing.
N222, it's a very commonly used transistor. Rating. Okay, see where it says collector emitter voltage. You see that?
Yes.
That's 400 volts DC. That's good. Collector emitter voltage. Emitter base voltage. You see that?
Yeah.
9 volts. So you can't use
9 volts to
12
trigger it. Okay. So it's a little bit more than the other transistor that was on the diagram, but still. Okay. That makes sense.
You can't use 12 volts to trigger it.
I mean, I use a 12-volt battery all the time with the system, so it might be because I have the resistance on the base. I don't know.
Wait, base current. Oh, okay. Whoa, collector.
But I did. Now that I'm thinking about it, I did mess with the resistance on the base for tuning it specifically with that transistor. I can't remember what I changed it to though.
So,
It's insane though. It could take up to 12 amps. Holy shit.
yeah, your emitter base voltage, 9 volts. You know, you were using a different transistor though when you had 15 volts there.
So I never actually input 15 volts. That's on the diagram. Michel has a power supply that he used 15 volts for the system. I never actually used 15. I always stuck with 12.
And what was it? What's that transistor you had on the other side?
So the original diagram calls for a MJ L21194. I think, yeah.
MJ-L21194.
I believe so, yeah. And if you want to compare those.
Oh, there it is.
No, this one I believe has a higher base voltage to trigger the transistor, but it's beefier, and I think it's faster, if I'm not mistaken.
MJ-L21194.
Yeah. But Gerald uses the E series, and it seems to work good for him, so I tried it, and it definitely worked here.
There's a PNP version, MJ-L21193.
Are you serious?
Yeah.
Oh, so that's the one we need to look at. What was the number again? Hold on.
Well, here, this one's got a lower voltage on the emitter base. That's the 5 volts.
Well, no, I need to look at that because the MJE or the MJ L21194, that works fine for the system.
At what voltage?
It works at a lower voltage than the E13009.
What were you using?
I'm just using a 12-volt battery, but I also started it on a 9-volt battery. So, I mean, they both start on 9-volt batteries. My point is that if the E series doesn't work with your system, I can try this transistor because it has a direct counterpart for the PNP. You see what I'm saying?
Well, your base emitter, your trigger voltage on this is 5 volts max.
Oh, so it triggers at 5 volts.
Yeah, so that's what I'm saying. You can't 12 volts. The other one was 9 volts. The other one we're working with now. The one we're currently using, yeah, 5850 or 13009. Which one is it? 13009 has.
I mean, I can't give you an answer why it's working, but it works with the 12-volt battery, and the trigger for this one
5850. Let me look up 5850. Hold on.
But the trigger is 9 volts for the E series, and it works fine.
Is it MJE, right?
Yeah, MJE.
MJE 5850. All right, let's see here. Emitter base voltage, 6 volts. Yeah. You can't send more than 6 volts into that one. So, let's do this. Ask AI. You want to use 12 volts, so you can't trigger 12 volts. I mean, there's going to be a voltage drop because of the resistor.
As long as the gate isn't oversaturated and on all the time, it should be fine. I mean, you would think there would be a maximum voltage tolerance too, right? For the base.
That is the maximum.
That is the maximum? Oh, I thought that was the minimum to trigger it. You sure that's not the minimum voltage required to trigger the base?
Let's see here. Emitter base voltage 9 volts. Maybe that's the minimum. Maybe.
Okay.
I don't know.
I just it works on my
let's ask
system.
AI.
So,
Let's ask
yeah,
AI.
ask AI because I
Thank
don't know.
God.
It just works, and I can't explain
Thank
it.
AI. Hold on. With transistors that can handle 12-volt emitter base voltage include many types of bipolar junction transistors, such as the 2N222, the 2N2907. Okay, whatever. What's the? Give me the one we're using now. The number of the one we're using now. What is it?
E13009.
Yeah. Okay, let's do that one first.
Yeah.
Let's ask the AI. What is the maximum emitter base voltage of the E what?
E13009.
Let's see what AI says. 9 volts. So the maximum emitter base voltage of the 13009D.
I actually have the L series. Maybe the L series is different.
What's the full number of the transistor? The E or the more than E?
So
MJE. MJE. Come on. AI needs the M and the J. Trust me.
But MJE.
Yeah.
Well, I mean, my transistor sometimes only says E. It doesn't say the MJ, so I don't know.
7 to 9 volts. So what it says on the chart is the maximum.
Make sure it's the
9
L
volts.
at the end.
MJL?
MJE 13009L.
L.
Yeah, it
5
says
volts.
max base. Yeah, 9 volts. That is weird. So am I like with the
Well, the L version is 5 volts. It's less.
But with the potentiometer and the resistor there, does that just bring down the current, or does that bring down the voltage too?
Brings down the current, but the voltage comes out at the other end the same as it goes in.
So I don't understand.
Okay. What is the voltage with 12 volts source across a 1K ohm resistor? Okay. It's 12 volts. Yeah, it's 12 volts. The voltage across a 1K ohm resistor connected to a 12 volt source is 12 volts. The current is the only thing that changes. Now, what if you have,
So it might be oversaturating the transistor already. Is that the implication here? We might be not getting the right timing.
I mean, you have a resistor there protecting the current from burning out the transistor, but it's not designed to be pushed more than 9 volts.
Interesting. I just don't know enough about transistors to comment on why.
Well, let's find a transistor that can do it. Hold on.
Okay, yeah, let's do it, because that might
What
actually...
transistor can handle? You want 12 volts? Let's do 15.
Yeah, 12 volts.
You want to have a little plate in here. 15 volts.
And it has to be high, like fast switching speed.
Nothing at 15 volts. So let's go with.
Let's do 12 because 12 is the most common battery that's around, and I want to eventually get the system running mobile.
Yeah, that's the 2N222, but that's the
2N22.
low current transistor, if I remember correctly.
I mean, it
And
still
the
might work.
2N907 is a PNP. Let's look up the chart for 2N222. It's not going to have a 400 volt.
Right, but I mean, as long as it doesn't burn out at like 160 volts or 180 volts, we're fine, because I think that's the max.
Well, it is an amplifier transistor, so wait a minute.
Well, those usually are pretty beefy, right?
Emitter base voltage is 6 volts. Yeah, that's the 222A. Hold on.
That is interesting.
Et pris de romance, dans les ruelles on explore.
Yeah, we keep hearing this on repeat here.
L'amour fleurit.
I have to upload some new stuff. Actually, this is a good track here.
Repeat this process.
Yeah, 2N22 is
But what you really want to do is you want to go as fast as you can without a capacitor.
voltage emitter base breakdown 7 volts. Yeah, 75 volts on the collector emitter. So AI is wrong.
Yeah, because if the transistor's oversaturated, it's just going to remain on all the time or not fully switch.
Whoa, look at this. What AI is totally wrong here. It's AI says max. It says maximum base emitter voltage on the 2N222 is 40 volts.
That's a tiny one, isn't it? That's that little tiny one. I think I have some of those.
2N222 right here. Yeah.
Yeah, those are the little tiny, kind of semicircle ones.
Yeah.
Those things will burn up with like fucking 25 volts, won't they?
You know, yeah, they're not designed for heavy loads. But it also has other, it has 2N907 and the tip 31.
The tip 3055 is the one that Daniel worked with.
That can handle 40 volts. Let me just see what the chart is on that.
Uh-huh.
Maybe that's better.
Yeah, maybe we'll go with the tip.
Yeah, tip 31. No, sir. What do we got here? Voltage, emitter base voltage 5.
Oh, I have that in my chart. So
Dude,
tip 30.
AI is so wrong, dude.
Dude, you gotta
Collector
watch
base
it.
voltage. It's giving me the collector base voltage AI, which is 40 volts. Collector emitter voltage. We're looking at emitter base voltage, not that. Did I type it wrong? What transistor can handle 12 volt emitter base voltage? Okay, let me take out the 12. What transistor has the highest emitter base voltage?
I could probably, if we can't figure this out, I could send an email to Michel and see what he thinks is the reason behind it, because he designed that circuit that way. Maybe he has an answer.
AI is so whack. And here it says 6 or 7 volts. The 9 volt one was the one we're using now. This is pretty much the nice one. Let me keep asking. You gotta just emitter base voltage. Which? Just say which instead of what? Which transistor has 12 volt emitter base voltage?
Je voudrais marcher sans que rien ne me guide, tomber, me relever, choisir mes pas timides, sentir mon cœur courir, battre un peu de travers, être un vrai garçon juste une fois sur la terre.
NPN transistors can be used with 12 volt as long as the collector voltage is also appropriately set to allow for proper operation. I guess you can use up to 12. Yeah, I don't know. Still not an answer here. Transistor with
J'invente des souvenirs, des genoux râpés, des colères et des dimanches à courir.
12 volt emitter base voltage.
Je voudrais marcher sans que rien ne me guide.
Okay, look at this. Using a 12-volt signal at the base of a transistor is possible, but the collector voltage must be more positive than both the base and emitter for proper operation. Ensure that transistor specification support configuration.
So as long as the coil on that side is outputting more voltage than it's putting into the base? Is that what that means?
Yeah. Okay, so collector emitter voltage must be higher than both the base emitter voltage.
You said the collector emitter voltage must be higher than the base emitter voltage?
Yeah, yeah. See, the Joule Thief is using like a dead battery, a AA, you know. One
I mean, it
volt or
can.
less.
But
When
what
a
it does
12-volt
very well is it stabilizes
Here.
and uses just the minimum amount needed.
When using a 12-volt signal at the base, ensure that the transistor is rated for such voltage and that the circuit configuration adheres to the necessary voltage relationship for optimal performance. Okay. Yeah, 12-volt PNP bipolar transistor. Emitter voltage, collector emitter. Mouser allows you to search by rating, so maybe we can find it that way. Where is that? Mouse. What happened to mouse? Oh, mouse up here it is. Mouse. We'll do that. There you go. So Mouser collector base emitter base voltage. See, 7.5. That's the highest one they got. The one that you already have is 9 volts. Try another website, I guess. What was that? DigiKey, there you go. They told MOSFETs they take a little more voltage, something. The base.
Ich tanze, Augen zu. Der Bass spricht, nicht du. Ich tanze unter Strom. Zeit zerfließt, kein Morgen,
Let's see.
kein davor. Kick schlägt, Herz schlägt, gleicher Takt, gleicher Schlag. Ich tanze tiefe Nacht, Schweiß auf Haut, alles wach, Stimmen fern, doch ich hier, Licht zerbricht über mir. Ich tanze.
Which one?
Immer tiefer, immer weiter. Kein Zurück, nur Bewegung, nur jetzt, nur der Raum, der mich setzt. Ich tanze.
Again, that's what I say. It's not giving me a base and minute roll. Until I pick a transistor, I'm not going to see the chart.
Was übrig
It's okay. I'm gonna probably pick this up tomorrow because I'm getting a little tired.
tanze.
You want to hit the video games, huh?
Yeah, I'm gonna get some gaming in before I crash. I'm gonna be like Phil, falling asleep.
Nur Pflicht. Ich tanze.
Are you gonna be streaming tomorrow?
I don't know. I mean,
Ich tanze.
should be. Yeah, try to.
Well, yeah, if you are, just shoot me an email.
Base emitter voltage next to it.
Ich tanze.
All right, well, let's just quickly go over this circuit. We could always continue this later.
Yeah,
So let's just round this off and crop this image
okay.
and go over it one time.
Yeah, we got pretty far on this tonight, actually.
Yeah. Let me just clean this up here. All right. Let's export that. What do you want to call it?
The circuit?
Yeah.
I don't know.
Modified POE, flyback, recovery, then project.
Yeah, like impulse recovery. I don't know.
I just put it in there and save it as that, so we have it. All right.
Especially if it starts working, we're gonna definitely name it something cool.
I think it'll work. You know, I mean, because I think you're right about the 12-volt thing, base emitter, and all that. Then again, there is a coil here. Let me do something real quick. What is that coil? What is the resistance on your vortex coil? 6 or something ohms?
I think on the one it's 8 ohms per channel, if I'm not mistaken. And I think one of the coils is about 4 ohms.
Should be, the voltage doesn't change. The current's not going to change. The voltage across a coil of 4 ohms of resistance connected to 12-volt supply would be 12 volts. Yeah. Still 12 volts. So anyway, and there's the circuit. We have it, and let's go over it. You ready?
Yep.
We'll do the trigger path first.
Yeah, the channel A.
Oh wait, hold on. You ready? Ready? Then?
Yeah.
All right, we're going to send 12 volts out the battery in the emitter of the PNP, out the base, through the coil, through the resistors, to the base of the NPN, out the emitter to negative of the battery, to trigger the transistors to close. And now the transistors are closed, and 12 volts can channel through the transistor gate and power up the power coil. Oh man, I got something wrong here. Yeah, that's all right. Okay, power up the power coil and go through the load to ground. Whatever the load doesn't use, it's positive flyback. Oh, actually, sorry. What am I doing? What is that? Yeah, so the 12 volts goes to the. What the hell? Excuse me. I hate it when it does that. Okay, so 12 volts. We close the gates. We trigger the transistor. Dude, come on. What is this thing doing? Had the wrong setting on my program. So, we closed the gates. We triggered it earlier. Triggered the transistors to close. Power leaves through the gate of the transistor into the coil. I'm sorry, that's incorrect also. Well, we got some errors here, man. Good thing we did this. I got that on the wrong side. Positive.
Oh, sorry, my mic was off. I was saying it's okay. It's not something that we want to rush, anyways.
No, you know what it is? I got this diode in the wrong direction here. This diode is facing the wrong direction. If we didn't do this, I wouldn't have seen that. Use that. Use this. This diode is facing the wrong way.
Vielleicht sind wir nichts weiter als das, was bleibt, wenn der Sound verklingt. Erinnerung.
All right, that's the correct direction. Okay, now positive goes in there. Oh god. I had that stupid red line in there. Okay, now we have it corrected. That's correct. Yep. So when the positive goes in there, it gets blocked. You have to go this way. Yep. Are you ready? I fixed it.
Okay.
Alright, I had the diode facing the wrong way. If it was facing the other way, then the positive would leave the battery and it would go, you know, into the ground like that. But now it's being blocked by the diode, the high voltage diode blocked, you see. So instead it goes the other way through the coil. And yeah, it could go this way back to its own positive, right? But that doesn't do anything. Positive hitting
Right.
positive doesn't do anything. You have to hit negative. Positive has to hit negative.
Right.
So it goes through
okay.
here and it hits negative through the gate. It hits negative. And charge it to coil. You put positive here when you charged it and negative there. Now the polarity flips. You have positive here and negative here. Oh wait, I got that wrong. Sorry. When you charge the coil, you put positive here and negative here. Here's the positive. Okay, are you following?
Yeah, sorry, my mic was muted.
Just making sure. So then you put positive there from the battery, and then it inverse polarity. Positive ends up here, and then the positive flyback can go. This is open now. Positive flyback can go through the load to negative. Okay, and it can also go through
Right.
the high voltage diode to this positive, out this ground port, back up here to this diode to reach the negative. Did you follow that? Okay, so this positive
Mostly.
flyback, this, listen, you watching? This, you watching? Ben?
Yes.
This positive flyback has to meet this negative, okay? Okay? Okay, so it's going to go out the coil, through the high voltage diode, hit through the positive of the battery, out the negative of the battery, up here, right here, you see this?
Yeah.
To meet the negative. That's how it meets the negative. Okay? That's how the positive flyback meets the negative of the flyback.
Okay.
But it meets the negative of the flyback through the battery, which is how the battery gets charged. So again, this positive flyback meets the negative flyback through the battery.
And that's the reason why it wants to go through the battery in the first place, is it's seeking
Yeah,
out
that's
that. Okay.
yeah, that negative sign is just the same connection point.
Interesting.
It's like drawing a line from here to here on the circuit. It's the same thing. So if you
Oh,
have
I
that,
know. It's just something like I'm thinking about.
okay. So you followed that?
Yeah.
Okay. So again, the positive flyback will go through the load
Yeah. Interesting.
to
Yeah, you're drawing it
here
through.
also,
Okay, so it's going. Okay.
and it meets the negative flyback right here, right?
Right.
And this load is powered by the flyback. This is the flyback polarity. That's what's powering the load, the flyback. So that positive flyback has to meet the negative flyback to power the load. And that's how it meets the negative flyback. Whatever the load doesn't take in positive flyback will go this way through the battery.
And get recycled.
And meet the negative flyback. So at the same time that you're hitting the load, you're hitting the battery. They're technically in series. Or right now they look like they're in parallel, but or maybe I'm seeing this wrong. They're in, yeah, I don't know. Maybe the other one. Let me see. Yeah, so I'll send you this schematic in your email.
Yeah, send me an email. I might run a simulation or two before I decide to actually run it.
You should.
Yeah, and the Falstead simulator is pretty good.
Well, in my circuit, they're in series. The battery and the load's in series. And in this circuit, so the diode comes after. Well, actually, it's the same. Yeah. No, wait, it's not. It's a little bit different in my. They're in series. The battery and the load. Is this in series? I can't tell. What's going on? Maybe it's not in series, it's in parallel here. Huh. I'm hitting the positive there. Out to the negative. Well, actually, technically it is in series. But it's going the other way. Positive to the negative, up to the negative to the road. That's positive flyback. That's negative, so positive flyback goes to the negative. Strange. There's a little bit of a difference here. Let me see. Positive goes through the road, out to the battery, through the battery. Let's see. Load on the batteries. There's a small difference here. It's in parallel. So the flyback goes through the load. Up. Positive flyback. Maybe here, what else is going? Probably move. Alright, well, I mean, I'm gonna make some changes to this before I send it to you.
Okay, sounds good.
I'm gonna try to put the load and the battery in series instead of parallel. Right now it's in parallel. So I shouldn't put that there. Here, the quantum planet goes out there. All right, I'll let you go, Ben. I know you're getting tired there.
Yeah, I'm falling asleep, unfortunately.
All right, talk to you Sunday, I guess.
Yeah, I'll
make some
see you
changes to this.
tomorrow.
All right, man, take it easy.
Later. Bye-bye.
Later.
Kalter Film auf meiner Haut. Dein Atem brennt. Doch ich bin taub. Fremder Blick in deinem Bett. Alles warm und trotzdem bleibt.
That's the problem.
Frost unter der Haut. Tief in mir. Tief in mir. Frost unter der Haut. Ich erfriere. Ich erfriere. Frost unter der Haut. Und du merkst es kaum. Frost unter der Haut. In dem viel zu lauten Raum.
Oh, that's what it is.
Deine Hand auf meinem Hals. Schwerer Duft.
There goes that.
Verrauchter Raum. Deine Worte fallen flach. Meine Puls laufen stumm im Takt. Frost unter der Haut. Tief in mir. Tief in mir. Frost unter der Haut. Ich erfriere. Ich erfriere. Frost unter der Haut und du merkst es kaum. Frost unter der Haut in dem viel zu lauten Raum. Ich atme ein. Ich atme aus. Doch ich bleib eingefroren. Du drehst dich um. Du drehst mich laut. Doch ich bleib eingefroren. Frost unter der Haut. Tief in mir. Tief in mir. Frost unter der Haut. Ich erfriere. Ich erfriere.
All right. Let's go over it one more time and then we'll call it a day. Positive leaves the battery, goes in the emitter of the PNP, out the PNP through the trigger coil, through the resistor, through the potentiometer, in the base of the NPN, out the emitter of the NPN to negative of the battery, and triggers the two transistors on a double pole action, triggering the positive of the battery and the negative of the battery, the positive of the source and the negative of the source to connect the positive of the source to the finish of the drive coil and leave out the start of the drive coil to hit the negative of the source, thereby charging up the battery. That lamp. You look at that. Right, so I may not be able to use that lamp because it's a 24 or 12 or 24 volt lamp and you're putting 12 volts on the source. So let's change it to a 90 volt neon. You don't want to be using the lamp on it. If you have it a 12 volt lamp there and a 12 volt source, your 12 volts will leave through the lamp and just go like that. And the lamp will be using the power. There's another error. Let's change that to a 90 volt neon. Just leave it at two. Two of them are 90 volt neons. So they'll act as indicators to let you know where the flyback's going. Oh no. Hit it again. Just do it like that. 12 volts. I mean, the 12 volt lamp, or 12 or 24 volt automotive lamp was good for the other circuit where the source was 5 volts. But the source here is 12 volts, so we're going to switch it to a 90 volt neon. That way it only goes off when there's more than 90 volts. And the purpose of that is to indicate if the flyback is taking that path. So the flyback polarity is right here on the power coil. It would exit this way. This is open when the flyback happens, so it doesn't go that way. It goes through the lamp, the 90 volt neon, out the high voltage diode. And to get to ground, it would have to go through the battery. To get to the negative flyback, it would have to go through the battery. And charge the battery as well. So this circuit will be a battery charger, or I don't know, it would be a power recycler, looper, or whatever. It would pulse the load would be the coil. So you know when you pulse this coil, you can use the EMF to spin a rotor with magnets right here. You can make that coil a U core and utilize both poles with a rotor and magnet on both sides if you want. With 2 rotors, 2 magnets. Or you can change the shape of the core and spin 1 rotor. You know, with a U core, you can spin 1 rotor. If this was if you had a U core, like so, you had a magnet here on the rotor, and a magnet here on the rotor, and a magnet here, and a magnet here on the rotor. Well, that's how the north and south of the U core would be pushed. So you would have north and south magnets on that rotor, which is cool because then you can pass those same north and south magnets, pass it by a stator on the other end. You could put another U core here as a stator. Use it instead of a drive coil, use it as a pickup coil. And that would be your stator coil, picking up the power. So that's what I would do to utilize the field coming off this when you do give it power. As of now, it's just doing nothing but getting energized, and maybe if it's a vortex coil, then you can use put a shaft with a magnet in the middle of the shaft and put the magnet in the middle of the vortex coil and spin the shaft. So, yeah. So the flyback comes out here again, cuts through the load, and it has to cut through the battery to get to the negative flyback and complete the cycle. The battery should provide a path to do that, whether the battery is charged or not. If the battery is low, it'll recapture some of that power while providing a path for the remainder of the amps that the battery didn't use. So if you find that this neon's going dim, the battery's probably low. And if the flyback coming out of here, positive flyback, cuts through the load, sorry, positive flyback cuts through the load. If it tries to go through this PNP and out here to meet the negative flyback and trigger these transistors, well, that's why you have this 90 volt neon lamp. It should provide a path for the flyback to go instead of triggering the transistor. And if that neon lamp goes off, then you know that it's time to add more batteries in parallel with the source to suck up the flyback, because you know that means you don't have enough battery space to take the flyback, so it doesn't go anywhere else. All right, so close out on this one. This one's good. Let me export this. And we'll go over the Pachuka circuit real quick. I already got that one pretty much figured out how it operates. I'm pretty sure I know how that one's working. All right. What that was showing on the screen. Hey, Lan. What's up, man? Good evening, John Gray. Oh, God, I'm going to go over this Pachuka circuit. You can see the link in the description on his idea. He's got a nice little experiment going. So let's bring that up. Yeah, very interesting. Let me first play his video. You guys tell me what you think. I gotta download it. Oh wait, I already have it. Where is it?
Je voudrais marcher sans que rien ne me guide, tomber, me relever, choisir mes pas timides, sentir mon cœur courir, battre un peu de travers, être un vrai garçon.
Check this out.
Еще эксперимент. Вот такая вот схемка БГТ с самозапитом. Давайте попробуем ее реализовать. Поехали!
There you go. Look at this. Okay, so he solders. This is the power supply, the 9-volt battery. There's a capacitor there, right? And that's it. So he gives it an initial charge, and it self-loops while lighting the bulb. Now you see the pancake coil and you see the Tesla coil, and that's in the circuit. Look at that. So he just tapped the positive. Look, just taps it. That tap is all you needed to get that capacitor charged enough to self-oscillate. So it's self-oscillating now. Looks like a 4-watt bulb. 4 volts or something.
А вот Еще эксперимент.
9 volt.
Вот такая вот схемка БГТ с самозапитом. Давайте попробуем ее реализовать. Поехали.
I'm going to go over how I think this is doing the loop, the self-running right now. Where is it?
La poussière dort sur la scène.
Okay.
Piano baille l'accordéon.
How do I think this is
La
working?
violoniste range son archet.
He sends positive out here. I already looked at this. It goes in the PNP, out the base, in the emitter, out the base, through the 10K resistor.
Des colères et des dimanches à courir.
And
Je voudrais marcher sans que rien ne me quitte.
then it goes through this coil.
Choisir mes pas timides.
Before this gate closes, this has to finish its path to negative from positive. So it goes through that coil, which is the low resistance pancake coil. This is the pancake coil. This is the Tesla coil. This is his little transformer with the full bridge rectifier connected to it. So it continues through this coil, the positive from the 9 volts, through the 10K, out in the base, out the emitter. And yeah, that's it. It goes that way, okay? In the base, out the emitter to negative 9 volts. And that's how the transistors are triggered. And it's, yeah. Okay, so now the transistors are triggered and they're closed. So the 9 volts can now channel through here and here to negative 9 volts, charge up the pancake coil. And it can also go, yeah. So that's that. The Tesla coil is isolated, isolated. Yeah, it's a single wire, open circuit, isolated. So he just has, yeah. So that's how the pancake coil gets pulsed. That's what's being pulled. And so the positive 9 volts it's hitting the one end of the Tesla coil right here. So positive 9 volts to, I guess that's a symbol for a ground. Maybe that's ground. Maybe that's ground. I gotta find out. I think that's ground. You can see in the video. So yeah, the Tesla coil is getting 9 volts to ground through this path here. And then to ground, or negative 9 volts. And it's also getting pulsed at the same time as the pancake coil is getting pulsed. So these two are getting pulsed simultaneously. Am I correct about that? Testing 1, 2. Okay, so positive 9 volts is going through there. going in the emitter, out the base, through the transistor, through this coil, and then that triggers the transistors, and this goes to ground. So it looks like they're both getting pulsed at the same time. It looks like it. Although that would be kind of they're opposite. Wow. I don't know. Maybe that would be a problem. When those two close, it energizes that. For that. Oh, right. That doesn't close. That don't need to close. All it does, yeah, close. Looks like they're getting close at the same time because, you know, when the positive enters here, goes through here, and then this way to here. That's enough to close this gate, but and enough to close this gate. So as soon as, you know, at the same time those gates are closed, pretty much at the same time, this one's getting charged also to negative 9 volts. And then what I think is going on is so the gate's closed, and then you are able to send positive 5 volts through this coil. So that trigger coil also gets charged. Energized. And it gets energized at the full 9 volts, while the other coil gets energized at a lower voltage. See, that's the difference. That's interesting. How so? Well, this positive goes this way. The green arrow shows the direction of the the Tesla coil gets power. No, not that way. No, it doesn't go that way. It goes this way. So the Tesla coil is getting a lot less power. The primary coil is acting like a trigger pancake coil. So pancake coil gets full charge. Also, it acts like a trigger. Then after it's done triggering the transistors, it gets full charge. And the Tesla coil has to go through a 10K resistor to get charged. So the Tesla coil is less charged than the pancake coil. So it looks like the pancake coil is sending power to the Tesla coil. Power comes in. Oh, turn that. They're both clockwise, okay. So then the north is over here. South on this coil. And then it's because power enters this way. But on the other coil, power enters this way. So the north is up here. And the south is here. That's strange. North and south. Okay, so and then you got plus from the battery going this way. Through the capacitor to minus. So this is giving you 9 volts right here. Minus and plus. Which wouldn't do anything regarding the bridge rectifier. Why? Because plus gets blocked here. And minus gets blocked here. But what does that do? I think it's taking charge, it's not giving charge. That's what it looks like. So then you have wireless transmission over to here. To this coil. Sending a north here and south here from the coil to the left. That would be your plus. And this is your minus. North is the stronger field. So your plus will go through the rectifier out into plus of the capacitor. So your plus goes through here. One half of the bridge, the plus of the capacitor. Your minus will go this way. To the minus side of the capacitor, and that polarity on this pickup coil will charge the capacitor with that half side of the bridge, and that is the battery's polarity now. Okay, that's the source 9 volts doing that. Now let's open up the switches, open up the gates on these transistors and do the flyback polarity. So let's remember where north and south is on these coils. That was for the other, yeah, that's north and south, right, for that polarity, but this was north and this was south. This was south and that was north for the battery polarity, but now the flyback polarity is the opposite. So since we gave a plus from the battery here and a minus here, and let me see here. Let me write this down so I remember north and south. The plus was going through here to here. Oh, sorry. It was going. Battery plus was going through here, and it was going over to here. Okay. And we gave plus here from the battery and minus here from the battery. Wow. It's like an AC signal there. Crazy. So, let's see. What do I think is going on here in the flyback? So this is the battery polarity, not the flyback. Strange. Then again, remember, this field is a lot weaker than this field. It's got to pass through this 10K ohms to get charged. So it's a very weak plus and minus. Nonetheless, the plus will hit this side of the coil, and the minus will hit this side of the coil, stator coil, and this plus will go through the diode this way and charge up that side of the capacitor, and the minus will go this way and charge up this side of the capacitor from that weak field, the weak Tesla coil field going through the 10K ohms, I don't know, milliamp, very small. And then you send a strong field to the pancake coil. Battery polarity, not flyback. And the strong field is south here and north here. And I'm guessing in the south we'll just skip this weak field and go straight over to here. And the north will go right over to here. It'll go off the same half bridge side, the same side of the half bridge. It's a full bridge, but it's going out half of the rectifier. Same half as the weak field went through. Same half. So it looks like the Tesla coil's weak field was, I'm sorry, the other half, not the same. Yeah, the weak field was going this way and this way. So it was going through these two diodes, the weak field. And the strong field is going through the other two diodes. Wait a minute. That was the weak field right in the north, right? And the strong field is going through south, through the same diodes. And here's the north. Same diodes. So I'm guessing the other two diodes are handling the flyback. Okay, so let's switch to polarity now. This is now a minus instead of a plus. Plus instead of a minus. This guy doesn't fly back. He's not being switched. Is he being switched? No, it's not being switched. It's constant current. It's going through the in the emitter out the base here to 10K ohms. And then this coil and another 10K ohms. And that's constant power. There's no switching here. But when you energize this coil, it might cancel the flow to this guy. But then again, when you energize this coil here, whatever energy is going in that coil is going to go to this coil also. That's super interesting, man. Okay. So the plus energy on the battery, we already know it goes constant current to this coil. And then when the gates close, we know that this is being triggered. These two transistors are being triggered like this. That triggers them to close. I'll do that again. This is the trigger path to close these transistors. And then they close. This this guy has got constant current on it from the source. So its north field is up here. Continuous. Constant. But when these two gates closed, this charges up with a full 9 volts. No resistance. Now this guy has constant current, but very little current. It's got to go through 20 kilo ohms. So whatever charge you put on that pancake coil, it's going to go and hit that Tesla coil that has the constant current on it. It's going to hit it at a pulse. So it's a constant current and a pulse system combined. So then the south would be here and the north would be here because the current is going this way on a clockwise coil. And that's like AC there because you got south and north and south. You know, you got a constant north and south here. A very weak north and south. And then you're pulsing the south and north in the other direction strongly. Yeah. I'll take all this out now and do the flyback. So we put a plus here previously. Now it's flying back minus. And this side is flying back plus. This is constant current, so there's no flying back here. It's always going to have the north here. So it flies back. And where does it go? It can't go anywhere because the gate's open here. You got too much resistance here. Well, you got a lot of it. Some of it can go through those resistors, but it only go through. Yeah, only go through one of them because this flyback can go through this resistor. Can it trigger this? That's a negative flyback, so no. But the negative flyback here can land here. And the positive flyback has to go this way, and it stops here because that's a PNP. So basically, the flyback doesn't go anywhere, but wirelessly to this coil. It has to wirelessly move over to that Tesla coil. And once it gets to the Tesla coil, it's now the Tesla coil has constant current on it. And north and south like so, and then you're sending the north here over here, a very weak north with a high potential. So let's just say that this north hits over here, turns this south into a north temporarily. Briefly turns it into a north. Okay. And turns this into a south. And then that distributes right here, north and south, onto the stator coil. The north flyback goes through this positive diode to the capacitor, and the south will go through there to the capacitor and charge up that capacitor. All four of these bridge rectifier diodes are being used. Let me get this correct. This is the polarity of the battery, and it was going this way, see, to the other rectifier. So it's kind of an AC thing going on here. Hitting this, so this capacitor is catching the charge from this switching action and this constant current action going on. Constant current on the Tesla coil, switching current on the pancake coil, and then the stator coil is picking up all of that interaction, bridge rectifying, full bridge rectifying to this capacitor. That's your plus and your minus on the capacitor. And as that capacitor is receiving charge, it's sending it back to the source. I'm going to replicate this thing. This is super intriguing. I really want to know who, I don't know if Pachuka came up with this, or if he got the idea from one of Tesla's patents, probably. I would like to know. Where's his lamp? He had a lamp in here. Well, let's look at the video. I've been messaging him and translating it to Russian. He's not really responding. He's kind of responding in his videos by posting the circuits. I asked him if he had a circuit. He was already putting the circuits up. He puts all his diagrams up. Look, there's the lamp. And it looks like it's connected to the pancake coil. It's probably in series with the pancake coil back to the battery or something. Let me find it. See. He skips right through it. It's hard to see. Okay, so on the pancake coil. One end of the pancake coil, the other end to the capacitor. Oh, it's across the pancake coil and the capacitor. The positive of the lamp is on the one end of the pancake coil, and the negative of the lamp is on it's on one end of the other end of the pancake coil. So it's across the pancake coil. The lamp is across the pancake coil. There's the full grid rectifier. The link to this video is in the description if you guys want to see it. You should subscribe to his channel. He's got a lot of these different circuits doing the same thing. This is not the only one that lights up that light and self-runs, basically. Oh God! So that's my approximation of what's going on here. There's a DC AC. So this thing is DC, constant current, no polarity change. It's like creating one half of the AC polarity, even though it's DC. The fact that this coil will then interrupt it with the opposite polarity. And when this coil is no longer inducing anything, this polarity comes back right away because it's constant. So in that way, you're stimulating AC. So his lamp is across the pancake coil right here. I'm pretty sure that's the pancake coil. 'Cause it has, yeah, because it has less turns than the other one, which is the Tesla coil. And this one is the small coil connected to the bridge rectifier. We'll go back to the video. If you look to the left, no, I don't see it. Where is this third coil? I see the rectifier, the capacitor. It's got 3 coils in that diagram. Maybe there's a coil inside the rectifier. The rectifier with a coil built in?
Как сильно он жил на проходной.
А вот
Alright,
еще
I'll play this video and then
эксперимент.
call it a
Такая
night.
вот схемка БГТ с самозапитом. Давайте попробуем ее реализовать. Поехали!
Sorry guys, I'm not watching the comments. Apologize.
Я не знал, что подписал, я ипотеку взял.
Теперь я раб на 70 лет. Уж лучше б жил на проходной, и в ус себе не ду.
Проценты жрут меня живьем.
Как трудно в этом мире жить, бахтира всех кормить.
А почки у меня лишь 2.
За выбор свой я так страдал, без отдыха пока. Не ел, не пил, даже не спал. кинул в зал, как сильно он воспылал. Надеюсь, будет так всегда.
All right, hope you guys enjoyed that. We'll call it a night, guys. Thanks for stopping by. And probably do something Sunday, tomorrow.
Come on. Do it. 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 Who is doing it? Do it. Do it. All of it. Do it. Come on. Do it now. And I will do the rest.
Son of a bitch.
Where the hell is this? Get nested here!
It's on a timer.
All right, listen, hey, the bomb's on a timer, all right?
Ken, where the hell are they? Ken, tell me Nest is here.
Affirmative. We've cleared 43rd. They'll be there in 4 minutes.
They're not gonna make it. They're not gonna make it.
Okay. You're gonna have to do this. Do you understand? Now take a look at this and tell me what you see. Take a look at this and tell me what you see.
An SS-18 primary with a plutonium core. Bomb inside a bomb. It has a capacitor relay detonator, double pull, double throw.
Okay. You're gonna have to do this. Do you understand? Now take a look at this and tell me what you see.
Thanks for stopping in, guys. Hope you guys enjoyed that. See you guys Sunday. Stop in, present, chat, join the show. What's up, John? Thanks, John. We're going live tomorrow. Try to find some more material. Running out of stuff, but we'll figure something out. Have a good night. All right, later.